Right, well, we've had a crash on this where the indexing plate didn't pull back properly after it had indexed, and the program just carried on. And because this was, I don't know, 4mm or so further forward, the turning tools crashed into the chuck. So we have some damage here on the chuck. I suppose it's lucky that these are soft jaws, but we're only machining aluminium, so it's yeah, going a bit too fast, and the feed was a bit too fast, so that's the damage on the chuck jaws. And that's the damage on the tool holder. This is still usable, and we've put another tip in this. I've used it on a manual lathe since this happened, but yeah, that's taken a bit of a hit, as you can see. And these things are mounted upside down in this because the turret runs on the back of the spindle. So that would have hit there. So we've decided to delve into this to try and find the problem. We've had the back off of this before because we've replaced the positional encoder, which is inside here. Now you get to that from the back. So there is the back end of the turret. The turret on this machine is all hydraulically powered, and that seems to make it harder to take the thing apart and get at the bits that you want to get at. This box has been taken off. We've got the main hydraulic pipes feeding into this. Which we've obviously had to disconnect. There's wires as well, but they're signal cables. They're not power, if you like. So this has to come off, and then you can get to the main unit behind. And that there actually says index motor. So that's the thing that actually turns the turret around. This part here, which we've just pulled out because it fits inside, there's a gear on the front of this. Can you see that? And that's the encoder, an optical encoder driven from the other gear, which is right inside there. That gear is in the center of the turret, and that rotates with it. That gear drives the gear on the encoder, which sends a signal back to the main control to tell it which position the turret's in and which tool is about to be used. And then when the thing pushes in and out, the Hall Effect switch, where has that gone? This is the Hall Effect switch according to the manual, and that fits inside there. It's a bit hard to see. This is a right pain to get at, all of this stuff. Zoom in a bit there, you can see the gear that drives the encoder. Then this sensor goes in here. There. Oh, I cannot see this. Oh, wow, this is just so hard to get at. I'm seeing this, but I can't see it. Well, kind of in there. That's just about in position to where it fits. Really hard to see, really hard to get at. And what I found really confusing when I was trying to find a replacement for this, there are no markings on this thing to tell you who made it or what type it is or whatever. So you do Google search for Hall Effect switches and there's thousands out there, but not too many that look like this. If on the other hand you do a search for proximity sensors, which is what this is, you do find very similar looking devices with an M12 by 1mm pitch threaded body, but you get inductive sensors, you can get capacitive sensors, which this isn't. This is detecting the presence or the proximity of metal. The confusing thing about Hall Effect sensors when you look it up is that they say that they work by detecting magnetic fields, and I found something on RS, electrical component suppliers, that looked very similar to this, and then when you looked at the specifications it says that it must be used with a matching magnet. Very, very confusing. So yeah, is this a Hall Effect sensor or is it an inductive proximity sensor? Well, the manual says it's a Hall Effect, but whatever. We need to find out whether this is working. I don't know whether these things can fail intermittently, whether they can stick on, as it were. You'd think they're all solid state, they either work or they don't, but yeah, I'm not sure. We need to try and figure out whether this is actually working. And of course we can't power the machine up and get this connected up to the control with this being all open and all the hydraulic pipes disconnected. So yeah, we're going to have to try and figure if we can put some do some tests on this. And in the meantime we still have the problem that the turret doesn't want to pull back in the first place. There's two problems: the fact that it doesn't pull back when it's indexed, and the second problem being that that little sensor is not telling the control that it's out of position. So we're at this position at the minute with the back box pulled off, pipes disconnected, really hard to see what else is going on inside there. That gear in there, as far as I can figure, must move in and out as the tall plate pushes out and pulls back again. I've put a piece of metal on that gear. There's nothing magnetic on it, so the sensor is just detecting the proximity of it. So I really want to be able to find out a bit more about what moves this in and out, and then find out where there's definitely some slop in the drive somewhere, but we need to do a bit more dismantling before we can figure that out. Right now this turret plate is pulled back where it needs to be, and that is absolutely rock solid. There's no way that moves, and I can't pull that out either. I'm not sure exactly what's holding it there, because the hydraulic pipes are disconnected, but possibly there is still pressure inside. So what I'm going to do is take this plate off of the top here, and there are some control valves inside that. I'm hoping maybe if I actually take those off, it might release whatever pressure is inside holding this back. This is the drawing that we've got in the manual for the machine, service maintenance manual. I think there must be another one, because there's a parts list here, 2 pages of parts for the turret assembly. And there's not enough numbers on this drawing to cover the list of parts. But yeah, front view, that's the tall turret, housing behind it, and a cutaway view looking kind of from the front. So there's the turret here. That is the index motor, the hydraulic index motor. This bit here is the junction, big massive junction box on the back where all the hydraulic pipes and the wires go in, and that we've now taken off. Here, well, there's a 5-to-1 gear coupling going on here. Not too clear as to how that's fixed and arranged. Looks like that little gear that is a little gear on the end that drives the optical encoder. Yeah, I don't know. Something's got to slide in and out here, and it's not at all clear as to what exactly slides in and out and what pushes and pulls it. That part there, according to the parts list, is a Curvic coupling. So it might be interesting to see if we can take the front off and have a look at that. Right, I have loosened these valves here. They're just surface mount. The ports go straight into the casting, just sealed with O-rings, so they're just bolted down. So they are now both loose, so there cannot be any pressure inside anything. But this turret is still absolutely solid on here, cannot budge it. So I'm thinking that the Curvic coupling which is inside here, which is kind of like, from what I've looked up, looks like face gears, if you like, or face splines, but they've got a particular geometry about them, and I think they must act like tapers, so that once they're pulled together they lock in position. And I'm thinking that that probably requires hydraulic pressure to push that off. There's no pressure pulling it together, but yeah, it's on tight enough that it requires hydraulic pressure to it requires hydraulic pressure to push it apart. So, quandary, what to do with this? I don't know really what I'm looking for. If there's wear in the drive gears, there's nothing we can do about it. We're not going to be replacing them. I was just wondering if there were some keyways or drive dowels or something somewhere between the motor and this that's enabling the play to occur. Do I want to try and take the front off of this? It looks like I could take this off of the coupling if we look at the drawing. So it looks like we can take off the ring here at the front, and then screws behind which hold the turret plate to the front half of the coupling. And what sort of fit that coupling is inside here, I don't know. It might well be really tight. It might not want to come off anyway. And then that just holds the coupling on, and then it looks like there's some huge bolts which hold the turret plate to the spindle. And of course the other thing I need to consider is that this whole thing is quite a lump. And if I actually manage to remove that, I've got to somehow support it, because I ain't gonna just hoik that out with muscle power, I don't believe. If I try, I'm liable to drop it and not be able to get it back, so I've got to try and figure some way of supporting that if I'm going to take it off. Right, I need to take these two turning tools off, because it looks like it's not just this ring here, there's a kind of a flange behind it, and I think that's all one piece, so we need to take the tools off. So the tools are held in with a wedge system. Slacken off the bolts that pull the wedge in. Tighten up the jacking screw in the middle. Wow, there we go. And that is now loose. I could just slacken those screws off a little bit more. Now that will come out. It's a neat way of clamping. Let's get this other one out. Make sure there's no crap in that socket. That's that one out. Oh, no it's not. That's it. These were tight, I have previously loosened them. Now will that come off? No, of course it doesn't. It's not been off for, I don't know, 20 years probably. Wow. There's nothing holding it, but so these wedges have got to come out because they overlap on the inside of it. They're going to stop this coming out. Okay. Okay. Oh, that doesn't smell nice. Old oil and coolant. Well, I wonder when that was last taken off. We've certainly never done it. Possibly wasn't done by the previous owners, so I don't know, maybe that's never been off since the thing was first put together. Bit of accumulated rust from moisture that seeped through. But you can see we have 2, 3, 4, 5, 6, 7, 8 fairly big bolts in the middle, which I think hold this to the spindle, and then another 8 around the outside, which I think hold this half of the Curvic coupling on to the turret plate. And there are a couple of other extra screws. There's one there and one there, and it also looks like this has got jacking screws, which could be really good to be able to actually take this off of the spindle. Yeah, okay. That looks a bit manky. These might be a bit rusted in, maybe. We shall soon find out. Right, I've pulled out all the big bolts from the middle of the turret, and that has now come free, so the coupling was not holding it like a taper, because this is now loose. It's constrained. This is actually pulled out a little bit, and I think it's hitting the limits of the coupling. So we'll find out in a minute. I've rigged up this lash up of a support up here, which I'm hoping is going to support this when I pull it off. Oh, that does look a bit Heath Robinson. Well, we'll give it a go. I don't think I'll be recording this. Well, finally pulled this thing off. It really didn't want to know. I think it was just a case of where if you're not pulling something off straight, it gets slightly cocked and then locks in position. Did not want to come off the last little bit, but it's off. And I was hoping I'd just slide it along out the way, but yeah, my lash up with this chain and rod up here is not very clever. And I've got, well, I'm using a couple of ratchet straps. That one's not doing anything at the minute, but the other one is carrying the weight at the moment. So we've got the turret pulled off of the, or I should say the top plate, the tall plate of the turret, removed from the housing, suspended by some straps from a pole going across the top of the cabinet. And there you can see the Curvic coupling. The Curvic coupling is this thing here. One side on that and one side there. And it's very hard to see the profile of these teeth. I'd never heard of a Curvic coupling until I started investigating this machine. Gets mentioned in the parts diagram, and they're called because one set of teeth have got a concave profile, and on the other one the matching one that interlocks with it, they're convex, but looking at these, it's very hard to see that. But anyway, that's what locks the tooling top plate to the turret. I was a little bit surprised to find so many teeth here, because it's a 10 station turret. There are 30 teeth here, so in theory you'd think that it could find a position between the correct ones. Yeah, it must all be down to the encoder. Well, obviously the encoder's supposed to tell it where it's at and doesn't pull it into position until it's in the right place. But yeah, anyway, that's what it is. And there doesn't seem to be too much wrong with this. There's no chips or anything, no appreciable wear on any of this, which is quite amazing for something that's this old. But there was a lot of fluid, mush, whatever in here. Again, I don't know whether that would have caused a problem particularly. There is also a seal that goes in here, which I've just taken out to have a closer look at. Seal or a wiper, and where that rubs on here, there's some very pronounced grooves that almost look like they've been machined in, but I'm kind of thinking that they are actually wear grooves from the seal. So I did think that maybe we should get a new one to try and prevent the ingress of fluid into the back of here, but that groove is not going to do us any favours even if you put a new seal on. And it turns out that we can't find a seal anywhere, not in the UK anyway. Do some Google searches for the size that's actually written on the seal, and you can find them in Singapore or Hong Kong, places like that, but nowhere in the UK. And ordering it from abroad, it'll take 11 or 12 days to get here. We want to really have this thing back together, and I don't think the seal is going to make a huge difference to the way this thing operates. So we're just going to clean it up. Yeah, it's the remains of this fluid that's got inside here. It's a bit rusty, so we'll clean all this up. I don't know whether it needs to be lubricated at all. I don't know. Maybe a very fine smear of some waterproof grease or something, just to make it so that when it is misbehaving and it's trying to turn round and not finding its location, maybe it'll turn round a little bit easier and slot into place. I don't know, but that's what I'm thinking. We'll clean it up. Light smear of oil on that. Oil, or as I say, waterproof grease. Yeah, and put it all back together, because there's nothing obviously wrong with it. The other thing that I wanted to check out was whether there is actually any play in the drive. So the top plate bolts to this, and there is the tiniest bit of backlash in here. Tick, 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 tick. Which I can only assume is from the gears inside. And I don't feel inclined to try and take this apart any further. That doesn't seem to be terrible to me. Obviously we're only feeling it at so diameter, whereas if you're out here somewhere trying to push and pull the top plate, it's going to feel more, but I can't see that being a major problem either. So again, I think we'll just clean this as best we can. Yeah, that's not great on there, so we'll clean all this up, and then we're going to have fun trying to get this back into place, I think. And then of course the other thing we've been trying to figure out is whether this sensor is working properly. This Hall effect, according to the manual, sensor. Proximity sensor, we can be sure that it is at least that. So we've taken it out of the machine. I've got two of these connected to a 12 volt battery charger. I think in the machine it runs on 24 volts for the sensors, so 12 volts should be okay. And if we put a lump of metal next to it, we have a little light shining, which tells us that it's detecting something. So that seems to be working as it should. I should really try and get some kind of reading off of the output for this. You know, I was a bit confused at first because most of the videos and everything that I've been looking up about these things, they talk about brown, blue and black wires, with brown for live, blue for brown for positive, blue for negative, and black being the signal. Whereas this is old-fashioned red and black for positive and negative, and the kind of off-white for the sensor, for the output. So we should be able to get, oh, it's going to be a bit hard to do this, not enough hands I think. So and this is where we get PNP or NPN type sensors. Getting anything on there? Oh, there's a tiny amount coming through that. And if we put some metal ahead in front of it, get it to switch on, have we got a different signal coming through? I think it needs an actual load. Oh, come on. I'm not seeing anything here. I think maybe I've got it connected the wrong way around. Let's try. Let's try that and that. Yep. It's only 2 volts coming through with a 12 volt power supply. But that seems to be working, so I think again all we can do is put it all back together, make sure all the connections are right. Oh, I don't know. Yeah, that's about all we can do. Try and make sure it's all dry. Put it all back together and see what happens. Very frustrating. Something not right. But it might well be the main board of the control. So I think if we put all this back together and it's still misbehaving, I think that's what we're going to be looking at. This is the wiper that fits in here. And you know, it doesn't seem to be in too bad a condition. It's not particularly hard. You know, sometimes the rubber or whatever these things are made of get a bit hard, don't they, with age. It doesn't look particularly worn out either. What's the edge of that? So I don't know if a new one would be very much better. So unless we can get one the next couple of days, which looks unlikely, I think this will be going back. And again, we've cleaned this up. This is pretty manky. But I don't know if that would have caused a problem particularly. So yeah, this is going back. That goes back in that groove. And then yeah, we'll put it all back together and hopefully and see how it behaves. Well, it's all back together now. Turret back in place. Actually went back together, wasn't too difficult. Got everything back in at the rear end of the turret there. Hoses connected, wiring connected. And all we've got to do now is to see if it's made any difference and see if the damn thing actually works. Whoops, that doesn't sound good. Oh my god. What's going on? Okay. Yeah, no, it shouldn't be spinning round and round and round like that. But it has always been a bit temperamental. Oh well, we shall see. Have a bit more of a play with it tomorrow. See what happens.